Okay, so we're up to the next level of the calculations here. So in this one, what we're going to try to do is we're going to try to calculate the pH of each solution that we made as we were adding more and more of the acetic acid. Remember, we started with sodium acetate, the blue solution. It's basic. We're going to add to that the conjugate acid of sodium acetate, which is acetic acid. Acetic acid is a weak acid, so that should change the pH. In fact, what we'll find is it actually changes it into a buffer. Anytime that you have a weak acid with its conjugate base, or vice versa, you're going to have a buffer solution. So as we go through these calculations, you'll see, for example, we have the pKa of acetic acid. That should remind us of the Henderson-Hasselbalch equation, right? The pH is the pKa plus the log of the ratio of the concentration of the weak acid divided by the concentration, I'm sorry, the weak conjugate base divided by the concentration of the weak acid. So we'll do those calculations here. So let's begin here. The volumes that we were adding, 2, 4, 6, 8, those are really just there to show us which solution we're talking about. So in each of those, in the previous table, we calculated the moles of acetic acid that we were adding, right? So let's go back to that. See there right there? Those are the moles added. So if you remember what we can do, oops, we can hit equal sign, come over to the previous cell or the previous table, and then hit that one, and then hit enter. And then it should be smart enough to figure out to use the 3 numbers that come after that in the previous table, okay? Then we had the moles of sodium acetate. Now remember, this is the blue solution. That stays the same the whole time. You always have that 100 milliliters of the basic solution. We calculated the number of moles in that solution as well. It looks like we did that all the way back in table 2, and it was 0.001 moles. That's the number of moles of sodium acetate that was in that solution. So that's the same every time. In fact, there's a little asterisk there to indicate that, yeah, it's going to be the same every time. So 0.001, and it's the same. So I'm going to go ahead and fill down. Now we just need to do the ratio. The moles of the sodium acetate, that's the conjugate base, divided by the moles of the acetic acid. That's the acid, right? So equal sign, moles of the base divided by moles of the acid. And then we can fill that down as well. Okay. So this would be 2, 1, 0.667, and then 0.5. Now, when we have numbers like this, we don't need to have them in scientific notation. So I'm just going to switch this over to regular number. And we've got, it looks like 2 digits past the decimal point should be fine. Okay. So there's our ratio. So at the beginning, we have more of the base. By the time we're done, we have more of the acid. Okay. That should still be in the buffer range. Remember, the buffer range is when the ratio is between 0.1 and 10, right? 0.1 meaning 0.1, 1 to 10 ratio of base to acid. And then a ratio of 10 would be 10 of the base, 1 of the acid. Okay. Now we're just going to take the log of it because we're going to do the Henderson-Hasselbalch equation. So log parentheses 2. That should give us 0.3. The log of 1 is 0. The log of 0.5 is negative 0.301 approximately. So those look like good calculations. We don't need that many sig figs. So I'm going to reduce that. And there we go. Remember, if it's negative, all that means is that the numerator is smaller than the denominator, okay? And then remember the pH from the Henderson-Hasselbalch is you take the pKa and you add to that, so plus the log of that ratio. And there we go, we've got it, right? So we now have the pH of all of those solutions. So notice the pH went from 5 down to 4.4 as we were adding it. Also notice it never turned yellow, right? The original cuvette that you had when you did the spectra of the acid form had hydrochloric acid added to the indicator. Hydrochloric acid is a strong acid, so that's why it turned yellow. If you could make it more and more and more acidic, eventually it would go from blue to then green and then eventually to yellow.